Okay, so here is one where I personally probably wouldn't actually draw the coordinate plane, but we'll do it just to kind of get this intro done. So we have this. We're talking about due west. Okay. So I would read the question all the way through before you start drawing. So let's actually read it. 2 lookout towers are 50 kilometers apart. Tower A is due west of Tower B. A roadway connects the 2 towers. A dinosaur is spotted from each of the towers. The bearing of the dinosaur from A is north 43 degrees east. The bearing of the dinosaur from B is north 58 degrees west. Find the distance of the dinosaur to the roadway that connects the 2 towers. Okay, so you don't necessarily need the coordinate plane for this one. I will do it since that's what we've been doing. But here, let's fill this in. So Tower A is due west of Tower B. Okay, so I'm going to put B at the origin, and then A is due west of it. And we know that there's a road connecting them, and that road is 50 kilometers long. Okay. And then we have some dinosaur spotted from each of the towers. The bearing of the dinosaur from Tower A is 43 degrees east of north. So again, remember, just because this isn't at the origin doesn't mean that north doesn't exist there. So this is rotating 43 degrees towards the east. Okay, so I'm going to draw this. And then from B, the dinosaur is at a bearing of 58 degrees west of north. Okay, so you're rotating 58 degrees here. Okay, so here's your dino. Ooh, I'm going to draw one. Okay, so your dino's up here. So how does that help us? All of my information is outside of the triangle. But I can figure out what this angle is, right? Because it's complementary to this angle. So 90 minus 43, 47 degrees in there. And then I can do the same thing over here. So 58, 90 minus 58, 32 degrees. Okay. So what I have going on here is I have my dino. I have Tower A, I have Tower B. These are 50 kilometers apart. And we have this 47 degree angle here, and we have a 32 degree angle here. And then what the question asks us for is the distance of the dinosaur to the roadway. Okay, so distance from a point to a line is always perpendicular. But this is not an isosceles triangle, so we can't assume that A to this point is 25, right? It's not bisected. So the thing that we're missing is either AD or DB to be able to solve for that height. So once I know what angle D is, by doing 180 minus 47 minus 32, I can do law of sines to figure out either DA or DB. I'll do DA, it doesn't matter. So we're ignoring the red altitude right now. We're just looking at the white triangle. And we're going to do sine of 32 over x is equal to sine of 101 over 50. Cross multiply and solve for x. We get 50 sine of 32 over sine of 101, which gives us that x is 26.99. Kilometers. So this is 26.99 kilometers. Okay, so to figure out what the height is now, looking for this, we're just doing right triangle trig at this point, right? Because distance from a point to a line, again, is perpendicular. So we have our reference angle. This is 26.99. So sine of 47 is equal to h over 26.99. So h is equal to 26.99 sine of 47. So the distance from the dinosaur to the road, 26.99 times sine of 47, is 19.74 kilometers.